Thank you. All right, let's go.
So let's talk about conversion formulas. How do we go back and forth between polar coordinates and Cartesian coordinates? So what we'll do is we'll look at a point in the plane and we will imagine that we've described both the Cartesian and polar coordinates for that point.
Did you see? All right, this is a perfect example of both representations of the same point. Look, we have Cartesians, right? The rectangular coordinates. These are from 0 to the left. I'm sorry, to the right. This is the measurement x. And then up, that is the measurement y, right? This is how we measure rectangular coordinates, right? X comma y. But then the same point can be measured using the r, the distance from the origin to the point, r, and theta, the angle of elevation, right? So this is a perfectly good image showing you that one point can have both representations at the same time. All right.
So here they are, x, y, r, and theta. Now we're going to use some simple right triangle trigonometry. The ratio x over r gives us cosine theta, and the quotient y over r gives us sine theta.
All right, this is some trigonometry stuff. Now, we have seen this in the past, right? We have seen this in the past. These are trigonometry ratios. Do you guys remember SOHCAHTOA? Well, that is exactly what we're doing here. All right, let me make a picture of this so I can draw in the board. This is SOHCAHTOA. Maybe you guys remember like this. SOHCAHTOA. Did you guys remember what is this? Did you guys remember what is this? Please, somebody in the chat, explain to me what is this.
Pues que el seno se utiliza para, es opposite angle sobre hipotenusa y el coseno es, se me olvidó, adyacente sobre hipotenusa y el tangente es opposite sobre adyacente. Y ya, creo que eso es todo.
All right, thank you, Richie. All right, I was just writing down what you were saying, and you are correct. This is a cute word to remember, to memorize the trigonometry ratios, right? Well, that is exactly what the guy is doing here. If you guys take a look at the sine of theta, theta is this angle, right? This is the angle theta. Well, sine, according to SOHCAHTOA, is the opposite over the hypotenuse, right? Well, the opposite angle is this one, right? Y. That's exactly what he's doing here. Over hypotenuse, but our hypotenuse is r. That is our hypotenuse, right? So we have SOHCAHTOA, we have the first trigonometric ratio. And then again with SOHCAHTOA, you guys are gonna see that with cosine, according to this, cosine is the adjacent side over the hypotenuse. But the adjacent side is this one, right? This is the adjacent side, x. Well, that is what the guy has in here. Over the hypotenuse, this is the hypotenuse, right? Well, that is exactly what we have over here, r, the hypotenuse. So from there, we know that using SOHCAHTOA will give us some formulas that we can use. Now, how can we use this formula? Let me erase all of this. How can we use all of these formulas? Pretty simple. Take a look. What the guy did, what the guy in, I don't know, pretty much any mathematician is going to do now is isolate the variables. Look, if we multiply on both sides of the equation by r, what's going to happen is that here we can cancel the r's. And if we do the same down here in the second one, we're going to have r multiplied on this side and r multiplied on this other side. We can cancel these r's, right? So what we are going to have is an equation where the only variable is on one side of the equation is x. X equals r cosine of theta. And y equals r sine of theta. Meaning now we have our conversion formulas. Take a look at this.
So here we have simple equations which allow us to move from polar to Cartesian coordinates. If we know r and theta, we can quickly generate the values of x and y that describe the same point.
Beautiful. So what the guy is giving us here is, if we know r and we know theta, r and theta, these two values, r and theta. In other words, if we have the polar coordinates of a point, then we can change to Cartesian without having to measure anything. We can just put this in the calculator and we are done. That is it. That is exactly it. But we have to know the value of r and the value of theta. All right. This is easily shown with a couple of examples. Again, guys, if you like to write down notes or take screenshots, go ahead and do it right now. These are going to be the formulas to change from polar to rectangular coordinates, from polar to rectangular coordinates. The reasoning behind these formulas, we already saw it in the video. All right, moving on. Let's begin with a first example. This is where things are gonna get fun now. All right, we have our point in polar coordinates. We have 6, pi over 6. This is in polar coordinates, right? Now, how do we change it to rectangular? Okay, all we have to do is just use the little formula over here, right? That's all we have to do. Okay, let's do that then. Solution. If we plot this point, this is exactly the location. Look, 6, 30 degrees. 6 and 30 degrees. I know this is 30 degrees because I just did this changing in my mind. Pi over 6. Pi over 6 is 30 degrees. Now, if you cannot do this change in your mind, if you still cannot do from radians to degrees in your mind, that's okay. Just use the formula and use a calculator. It will give you that this is 30 degrees. Now, from here, if I plot this point, an elevation of 30 degrees, and then from 0, a measure of r, this is the location of the point. This is the point A. So we know from the drawing, we know that the Cartesian coordinates, the rectangular coordinates, should be 5 point something, right? Is 5 and a little bit more, comma 3. We know that. Just from the drawing, we know that. But now let's calculate exactly, precisely, what are the coordinates. This is how you do it. All right, so we notice that this point lies in the first quadrant on the plane. Do you guys remember the names of the quadrants of the plane? This is quadrant 1, quadrant 2, 3, and 4, right? All right, let's continue. From here, we expect both x coordinate and y coordinate to be positive. Again, we are seeing that in the drawing here, 5 point something and 3. 3, that's it. I don't think that's 3 comma something. All right. Now we know r is 6 and theta is pi over 6. So if we use this with our calculator, we just have to change the values of r by 6 and the values of theta by pi over 6. If we put this inside the calculator, we're going to have that x is around. Remember, this is a good use of notation. X equals, because of the formula, x equals because of all we did was replacing. But in here, we are doing a simplification. We are doing a rounding. So x is around 6 times this, right? Cosine of pi over 6 is 0.866. Now, how do you do this using the calculator? Pretty simple. All you have to do is write down in the calculator cosine of pi over 6, and you are good to go. Now, since we are using radians, you have to make sure that your calculator is in radians. If your calculator is in degrees, then you cannot write this. You have to write cosine of 30. Knowing what units are you using is extremely necessary when using the calculator in these exercises. All right, from here, let's multiply this, and we know that x is around 5.196. So around 5.2, around 5.2. And that's what it looks like here, right? 5.2. Beautiful. Now, can we do it with y? Can we find the coordinate y? This one? We know just from the drawing, it looks like a 3. All right, let's see if it is a tree or not. So we have y equals 6 sine of pi over 6. Again, all we are doing is changing the values of r and theta. R equals 6, that's what we have here. And theta equals pi over 6, that's what we have here. Putting this in a calculator is going to give us the sine of pi over 6 is 1/2. 6 times 1/2 is exactly 3. Again, guys, notice the usage of symbolisms. One thing is the equal sign, which everything in here is equal because we haven't round anything. And another thing is the symbol for rounding, for similar, which we have to use when we round. We are rounding here because we are writing some amount of decimals. These have an infinite amount of decimals. In this case, the answer is precisely one half, precisely 1/2. All right, so what are the coordinates in rectangular coordinates? The rectangular coordinates will be 5.2, 3, just like we guessed at the beginning. 5 point something, 3, 5.2, 3. Beautiful. That is it. That is how you change from polar to rectangular. Now, let's do another example. Maybe with that other example, we have some more questions about this. But so far, I'm assuming this is absolutely simple. How do we do when we have negative on both sides? All right, the first thing is to plot the point. So we have a negative pi over 4. Since this is negative, we are going to measure the angle downwards, right? From the x to the going clockwise, we're going to have to measure this angle. This is negative 45 degrees, right? Now, that is, and we know that pi over 4 is 45 degrees because all we had to do was use the formula to change this value. That was it. That was it. Now, in here, we would have to measure 4. But we are measuring negative 4. So instead of 4, we're going to have to measure backwards, going up. 1, 2, 3, and 4. Over there is the location of the point B, negative 4, negative 45 degrees. If you guys can hear that, then knocking on the wall, that is my neighbor who is doing something at 9 o'clock in the morning. Sorry, guys. All right, from here, we know that this point, the point that we are plotting, lies on the quadrant 2 of the plane. So we are expecting the x coordinate to be negative and the y coordinate to be positive, right? That gives us some information. Now, exactly how much, we cannot tell. We can kind of guess that the point will be negative 2, something. I don't know. According to this, negative 2.8 or something like that. And with y, it should be positive 2.8 or something like that. We can kind of guess, but we will not be sure until we do the translation, the converting from polar to rectangular. So to do that, we have to use the formulas, right? Here are the formulas. We know that r is negative 4 and theta is negative pi over 4. So we use the little formula for x and we replace the values of r and theta. R equals negative 4 and pi and theta, equals negative pi over 4. Okay. From here, just put this inside a calculator. Remember to use this symbol for rounding, and we have negative 2.828. So we were kind of close, right? We said negative 2.8, and this is negative 2.828. So if we round this to 1 decimal, we were precisely correct, right? If we round this to 1 decimal. All right, pretty good. We have the value of x, just like Juan Sebastián Parrado says in the chat. All right. But can we do it with y? Can we find the coordinate of y? Well, sure. All we have to do is just use the formula. Y equals r sine of theta. And replacing the values of r by negative 4 and theta by negative pi over 4 is going to give us that y equals, and this is a mistake, it should be a round. And this is a mistake, it should be a round number, right? This is a mistake. I'm going to change it for the next presentation. This is round and this is round. Because we just changed something for decimals. This is a rounding number, and this is a round number. So we have our value of what? 2.828. So what is the solution? Here are the polar coordinates of a number, polar coordinates. And the rectangular coordinates are the one in red, negative 2.8, comma 2.8. That is it, guys. That is just it. Changing from polar coordinates to rectangular coordinates is just knowing how to use the little formulas. And, of course, proper use of calculator. That is it, guys. For the rest of the class, what I want you to do is to practice some exercises. Now, guys, I want you to please ask me. Please ask these exercises. If there is some exercise that you don't understand, please ask away so that we can do them together. And I'm going to stop the recording here and let's get to work.